In question 16, it is given that a boy whose weight is 600 Newton, he runs up a flight of stairs 10 meter high in time 12 seconds. We want to find the average power. The average power is work done per unit time. Here work done by the boy is his weight into height, that is force into displacement, divided by time 12. 600 into 10 divided by 12. Simplifying this, we'll get answer 500 watts. So option 2 is correct option. In question number 17, a car weighing 1000 kg is going up an incline with a slope of 2 in 25. The meaning of slope of 2 in 25 is if it travels a distance of 25 meter along this slope, the height reached by the car is 2 meter. Let's say this angle is theta. At speed of 18 km per hour, that means V is equals to 18 into 5 by 18, that is 5 meter per second. We want to find the power of its engine. Power is equals to F into V. Force will be mg sine theta into velocity. Mg is 10 power 4 into sine theta. From this we can write sine theta is 2 by 25 and velocity is 5. So final answer will be 4 kilowatt. So option 1 is correct option. An electric motor creates a tension force of 4500 Newton in a hoisting cable and drills it with the rate 2 meter per second. We want to find the average power. Here the tension force is constant and velocity is also constant. So V average will be instantaneous is equals to force into velocity. So 4500 into 2, this will give 9 kilowatt. So option 2 is correct option. In question number 19, the elastic potential energy of the stretched spring is given as 50x square. We know the elastic potential energy stored in any spring is half kx square. Comparing these two equations, half kx square is equals to 50x square. X square will get cancelled out. So k will be 100 Newton per meter. The spring constant of the spring will be 100 Newton per meter. So option 2 is correct option. In question number 20, there are two blocks, one of mass 1 kg and another of mass 2 kg. Initially, this 1 kg block is moving with speed 4 meter per second and this block was initially at rest. Now, after collision, the lighter block comes to rest. That means this 1 kg block will come to rest. So V1 will be 0. We want to find the speed of heavy block, that is V2. Here there is no external force acting on the system, so we can use conservation of linear momentum, that is m1u1 plus m2u2 is equals to m1v1 plus m2v2. 1 into 4 plus u2 is 0, m1v1, but v1 is 0 plus m2 is 2 into v2. So v2 will be 2 meter per second. So option 1 is correct option. In question number 21, A ping pong ball strikes a wall with velocity of 10 meter per second. If the collision is perfectly elastic, then we have to find the velocity with which ball will rebound. Here the collision is perfectly elastic. In perfectly elastic collision, kinetic energy is conserved. That means there is no loss of kinetic energy of this ball, so it will have same speed and it will bounce back in the exact opposite direction. So V will be minus 10 meter per second. So option 4 is correct option. Question number 22. There are two balls, one of mass 4 kg and another of mass 6 kg. This ball is initially moving with speed 3 meter per second and 6 kg mass was initially at rest. They collide. We want to find speeds of both the balls after collision. Here the collision is elastic, so both linear momentum and kinetic energy are conserved. We can write equation for both. So m1u1 plus m2u2 is equals to m1v1 plus m2v2, and for conservation of energy, half m1u1 square plus half m2u2 square is equals to half m1v1 square plus half m2v2 square. By solving these two equations, we will get equation of v1 as m1 minus m2 into u1 divided by m1 plus m2 plus 2 m2u2 upon m1 plus m2. Put the values. The u2 is 0, so this whole term will become 0. m1 is 4, m2 is 6, u1 is 3 divided by total mass 10. So this will give us answer minus 0.6 meter per second. From this equation, v2 will be m2 minus m1 into u2 upon m1 plus m2 plus 2 m1 u1 upon m1 plus m2. Here u2 is 0, so again this term will become 0. Put the values. 2 into m1 is 4 into u1 is 3 divided by total mass 10. This will give us the answer 2.4 meter per second. So v1 will be 0.6 meter per second and v2 will be 2.4 meter per second. So option 3 is correct option. Question number 23. A proton is moving with velocity 1.25 into 10 power 5 meter per second. It collides with a stationary helium atom. What is the velocity of proton after collision? Let's say mass of proton is mp and mass of helium is mh. Mass of proton is taken as 1 AMU, let's say that is m, and mass of helium is taken as 4 AMU, let's say that is 4m. It is initially at rest. This is u1, this is u2. We want to find the velocity of proton after collision, that is v1. We'll use direct formula. v1 is equals to m1 minus m2 into u1 divided by m1 plus m2 in plus 2 m2 u2 divided by m1 plus m2. In this case u2 is 0, so this whole term will become 0. v1 will be 1m minus 4m into u1, that is 1.25 into 10 power 5 divided by total mass 5m. Simplifying this, we'll get v1 is equals to minus 0.5 into 10 power 5 meter per second. So option 3 is correct option. In question number 24, there are two identical bodies having mass m. One is moving in this direction with speed v and second is moving in opposite direction with same speed. They collide and combine. So after collision, the total mass will be 2m. This is the situation before collision and this is the situation after collision. We want to find the combined velocity. Let's say combined velocity is v dash. We'll use conservation of linear momentum, that means delta p is 0. Initial linear momentum of the system. I'm taking this direction as positive. So mv minus this direction is taken negative. So minus mv is equals to 2m into v dash. So v dash will be 0. So after colliding, the both body will come to rest. So option 2 is correct option. In question 25, there are two masses. M1 is 16 gram and M2 is 4 gram. M1 is moving along positive x-axis with speed u1 is equals to 30 centimeter per second, and M2 is moving along negative x-axis with speed u2 is equals to 50 centimeter per second. Here it is moving along negative x-axis, so the velocity will be minus 50 centimeter per second. They collide and they stick together. So after collision, total mass will be 16 plus 4, that will be 20 gram. We want to find the combined velocity. We'll use conservation of linear momentum. Initial linear momentum is m1 u1 plus m2 u2. Final linear momentum will be m1 plus m2 into final velocity v. Here both will stick together, so total mass is taken m1 plus m2. Put all these values, 16 into 30 minus 4 into 50 is equals to 20 into v. So v will be 14 centimeter per second. So v will be 0.14 meter per second. So option 2 is correct option. In question number 26, a bullet of mass 50 gram is going with speed 200 meter per second. It strikes a wooden block of mass 950 gram and gets embedded in it. We want to find the velocity of block after the impact. Here the bullet gets embedded into block, so after collision the total mass will be 950 plus 50 gram, that will be 1 kg. We'll use conservation of linear momentum. Initially only bullet is moving, so mass of bullet into velocity of bullet is equals to, finally bullet is embedded into block, so both will move combinedly with same velocity. So mass of bullet plus mass of block into combined velocity v. Put this value is 50 into 200 is equals to total mass 1 kg, that is 1000 gram, into velocity v. So v will be 10 meter per second. So option 2 is correct option. In question number 27, a truck of mass 10 metric ton runs at speed 3 meter per second. it collides with another loaded truck of mass 20 metric ton standing at rest. After collision, the trucks couple together, that means total mass will be 30 metric ton. We want to find the combined speed. We'll use conservation of linear momentum here. Initial linear momentum is m1u1 plus m2u2 and final linear momentum will be m1 plus m2 into v. Here u2 is 0, put this values, 10 into 3 is equals to 30 into 1. So v will be equal to 1 meter per second. So option 1 is correct option. Question number 28. A rubber ball is dropped from height h and after rebounding twice from the ground, it rises to height h by 2. After second collision, it rises to height h by 2. We want to find the coefficient of restitution. We know that after nth collision, the height achieved by the colliding object is e power 2n into actual height. Here hn is given h by 2. It is second collision, so e power 4 into h. So e will be 1 by 2 whole power 1 by 4. So option 3 is correct option. In question number 29, a board is dropped from height h on horizontal plane. It keeps bouncing up and down. We want to find the ratio of velocities at the beginning and after two rebounds. Let's say it is hitting the ground first time with speed u and it is bouncing back with speed v after two collisions. We know that after nth collision, velocity will be e power n u. So after second collision, velocity v will be e square u. So v by u is equals to e square, or u by v is asked, so 1 upon e square. So option 3 is correct option. In question number 30, we want to find the ratio of time in two consecutive rebounds. We'll use h is equals to ut plus half gt square. Here u will be 0, so h is equals to half gt square. So for first collision, time will be 2h by g whole under root, and for second consecutive rebound, T2 will be 2 e power 2n h divided by g. Taking the ratio, we'll get t by T2 as 1 divided by e. So option 1 is correct option.